This is the training video for learning about how to interface with the tool using the LCD display and menu system. This video will also show you how to correctly charge the tool. We will be discussing the following items: turning the tool on and off, first message to appear, main display screen roadmap, alternate information screens, using the menu, charging the tool, tool troubleshooting, key point review. To turn the tool on, press and hold the power button for 2 seconds. This delay prevents inadvertent starting of the tool, which could potentially drain your battery. To turn the tool off, you only need a quick push of the power button. When the tool is turned on with the arms in the stored position, the screen will prompt the user to position the arms correctly. Correct positioning of the arms means that the two chevrons must line up. Be sure that the arms are correctly in the detent position. The arrows of the screen are showing the user where the arms are. The top symbol, representing the short arm, starts as a dash because there are no valid arm orientations with the short arm in the stored position. When the short arm is moved to the 90-degree left position, you can see that the left arrow appears. The arms are still not in a valid position because the chevrons are not lined up. In this situation, you can either move the small arm forward or the long arm out to the right. Once the chevrons line up, the arrows will briefly appear in the same direction, and then the screen message will change to starting solution. If you already have the arms deployed in a valid position prior to turning the tool on, the first message will be starting solution. As the system calculates an azimuth solution, you can observe a timer in the right top corner of the screen. If you have moved to a new site location or it is the first survey of the day, the first azimuth solution can take up to 3 minutes, but less than 2 minutes is typical. For subsequent surveys, the tool will usually take less than 30 seconds to get an azimuth solution. Now that the tool is providing a complete solution, including the azimuth, the main screen will appear like this. The azimuth appears here, and the tilt here. Note that the tilt uses an up and down arrow to signify up or down tilt. In this area, the tool's orientation and each arm orientation relative to the tool is being displayed. It is important to note that regardless of where the tool is facing in relation to the antenna and where the arms are pointing, the tool automatically calculates the offsets necessary to produce the azimuth, tilt, and roll of the antenna you are measuring. Let's look at a couple of examples of this. First, let's note the azimuth of the antenna and the position indicators. The azimuth is 90 degrees, and the tool is forward as seen by the F, and the arms are both forward as seen by the two forward arrows. When moving the tool to the right side of the antenna, notice that the azimuth is changing as it should right until the tool is placed in the right side mounting position. The tool automatically senses that it is to the right of the antenna and offsets the azimuth, tilt, and roll accordingly. Now, we will leave the tool in the right position and just change the arm position to the T position, both facing in the opposite direction of the antenna. Since the arms are temporarily not in a valid position, the tool will restart the azimuth solution. This is called a hot boot and will usually take under 20 seconds. When the solution comes up, it is the same azimuth, which is 90 degrees. Therefore, regardless of how the tool or arms are positioned, the tool will always provide the azimuth, tilt, and roll of the antenna being surveyed without any offset input from the user. It is recommended that the user visually confirms that the tool and arm positions are correctly being tracked by the tool. Also shown on the screen is the GPS integrity. This number is a confidence factor, so the higher the number, the more accurate your real-time azimuth accuracy. If the GPS integrity number is below 30%, it is signifying extremely poor GPS conditions or a lack of visibility of the satellites. The battery level is shown here. There are 5 bars in total, with each bar representing about 2 hours of operation time. The azimuth can be set to be relative to true north or grid north. North American RF engineers typically provide the antenna azimuths in true north. Some European engineers use grid north. There are 5 other display screens available. Pushing the down arrow will bring up the second screen, which shows the GPS position, AGL, and tilt and roll. This screen will automatically revert back to the main screen after 10 seconds. The third screen shows the firmware version, serial number, and what Wi-Fi channel has been selected. The Wi-Fi channel display can be useful if you are using the default Wi-Fi auto-select feature to see what channel the tool automatically selected based on Wi-Fi activity in the area. The remaining 3 screens contain diagnostic information in case you need support from Multiwave in solving a measurement problem. The user menu system can be invoked by pressing the Enter key. Once the cursor is at the menu choice you want to edit, in this case azimuth, simply press the Enter button to scroll through the menu choices, true or grid. After you have the setting you want, move to a different menu line or continue to exit and press Enter. The next selection is Location Format, where you can set the GPS position format on the screen. The units can be feet or meters. Sound can be set for events only, button pushes, and events, or turned off. Backlighting can be on, auto, and off. Auto uses an ambient light sensor to automatically turn the backlighting off when there is sufficient brightness. The Wi-Fi channel selection lets you use the auto selection mode or manually use whatever channel you wish. In North America, the channels can be set from 1 to 11, and in Europe, the channels can be set from 1 to 13. The last choice is Data Port. If this port is set to data, this sets the baud rate to 115/200, and if laser is selected, the port is set to 4800, which is the default baud rate for the optional TruePulse laser rangefinder manufactured by Laser Technology Incorporated. More information on automatic laser AGL use is covered in the options video later on. The tool can be charged with either the wall charger or car charger. Only use the chargers provided with the smart aligner system or damage could result. In this example, we are using the wall charger, but the car charger works in the same fashion. The charger port is located here on the back side of the display module. Once the charger is fully connected, the charging status will be displayed in this manner. You will also see the battery voltage in the top right corner. The battery charges to 8.4 volts and will automatically stop charging as shown. It takes approximately 4 hours to charge a fully drained battery. The tool displays charged with a long beep when the battery is fully charged, and the backlight will automatically shut off in 10 seconds. The charger must be disconnected from the tool before turning it on again. Note that if you repeatedly keep recharging an almost full battery, you will prematurely reduce the life of the battery. It takes a maximum of 10 minutes per alignment, so 1 bar of battery life should be ample to align at least 12 antennas, so judge accordingly before recharging the tool. How do I use the declination with the azimuth? You don't. You only use declination to change a magnetic reading to a true north reading. Since the smart aligner produces the true north azimuth, you do not need to worry about declination. What do I do if the azimuth solution does not come up in 180 seconds? The smart aligner tool is designed to be the most RF-resistant alignment system on the market, so it should work in the most demanding environments. If you do not get an azimuth within 3 minutes, you could be getting RF interference into the GPS antennas, which cannot be shielded. Try positioning the tool to the side or behind the antenna to see if it is being affected by the RF interference into the GPS antennas. I have the tool and arms in a different location than the antenna that I want to survey. How do I enter an offset? You don't have to. As long as the tool is correctly tracking the tool and arm positions, the tool will automatically incorporate the offsets into the calculation, and the tool will only produce the correct azimuth, tilt, and roll of the antenna. Key point review. You need to push the power button for 2 seconds for the tool to power up. The azimuth solution will not start to calculate until the arms are in a valid position. Make sure that the chevrons are lined up. The tool tracks its position around the antenna as well as the arm orientation so that it can automatically calculate the offset, thus producing only azimuth, tilt, and roll of the antenna. For demanding RF environments, attach the tool to the side or backwards to avoid RF interference. The second screen will show the GPS position of the antenna as well its role. Only use the chargers supplied with the smart aligner system. Do not charge the tool when there are 3 or more battery bars showing.